In the following sketch, ABCD is in a horizontal plane. This one, ABCD is A is directly above B. AB is a vertical line. AB equals H. BC equals X. CD also equals X. BAD equals alpha. And BCD equals theta. Show that BD squared is equal to 2x squared 1 minus cos theta. Now, a hint. What does this as well as this suggest to you? What does it suggest to you? I can only give you hints. First of all, this is H. The angle here is alpha. This is A. This is B. This is X. The angle here is theta. This is C. This is X. And this is D. What are we required to prove? We are required to show that BD squared is equal to 2x squared into 1 minus cos theta. What does this suggest to you? This is a square. This is a square. Two things should suggest to you two things. One, you are having a square. And two, the triangle is non-right angled. These two facts suggest to you that you must use the rules. Number one. Number two, which specific rule? The cosine rule. I said at the beginning, the square and the square root will immediately suggest to you what course of action to take. At any rate, the question itself is already written in terms of BD squared, so you don't have a choice, but the square, like I indicated, together with the fact that it's non-right angled, suggests that we can't use the definitions of sine, cos, and tan, but it also suggests that because there's a square, the one rule that involves a square is the cosine rule. And that is what then you proceed to use. BD squared will then be equal to, remember it is this side, it must be equal to the other two sides. X squared plus x squared. I'm skipping the BC and the CD story so that we can move fast. Okay? Is the square of the other sides minus twice times the cosine of theta. But what do you have here? This is 2x squared minus, what do you have? X times x. It is again 2x squared times the cosine of theta. What does your mathematics say? What does your mathematics say? I have two terms. This is one term. This is the other term. But in this one term, there's 2x squared. Also here, there is 2x squared. So we take the 2x squared out. And we are left here with 1, here with cos theta. It might have looked formidable to you. It might have looked completely difficult. But like I said, when you are in this, if the triangle is non-right angled, first of all we use the rules. And normally we use the sine rule. But if you have a square or a square root, then you know that you must use the cosine rule. So in this case, it is this side squared equal to this side squared plus this side squared, minus twice this side times this side, times the cosine between them, which is the cosine of theta. And when you simplify it, you notice that 2x squared is common. So you take it out and you are left with 1 minus cos theta. I think we've run out of time. But before we part, it is an open secret. It is an open secret that the Department of Free State, or rather Free State beat all the other 8 provinces last year with matriculation results. It baffled me because it had never happened before. So I did research, I found around, I visited libraries, I Googled, and guess what? I found the secret. And I'm going to give you that secret. They'll probably fire me for telling you that. And if they do, it's your fault. But I'll tell you all the same. They worked harder than everybody else. If you want to outperform anybody, you must outwork them. There's no circumventing that. I wish the audience, you were here as an audience, so that you could ask me questions. However, I hope you took down what I asked you to take down. Or let me leave this one here for you to take down. Because sometimes when one speaks, you want to concentrate, but at the same time, you want to write down. Let me go to the question. The question says, show BD squared equal to 2x squared. And let me repeat, a square, together with the fact that the triangle is non-right angled, gives us two things. The non-right angles tell us we must use rules because we can't use definitions of sine, cos, and tan. And the square or the square root tells us that you must use the cosine rule, which is what we applied here. And the cosine rule, if we understand it, says you take any side, in this case BD squared. Take the square of that. It is equal to the sum of the squares of the others. In other words, BC squared plus CD squared, which happen to be x, both of them. Minus twice those sides, not squared, the product of those sides, times, again, the product of those two sides together with the cosine of the included angle. And like I indicated, it's easy to identify an included angle. It is actually an angle made up by the very sides. So BC and CD make up theta. So the included angle between BC and CD is theta. So you use the cosine here. From here is simple algebra. X squared plus x squared is 2x squared. X times x is again x squared. Again, simple algebra. When you have terms joined by plus or minus, then you don't have one term but an expression. So this expression here consists of two terms, 2x squared together with minus 2x squared cos theta. But in these, 2x squared is common. That is why we take it out. And you may wonder why we have 1 here. You were actually doing this. You are actually multiplying by 2x squared divided by 2x squared, which is 1. And you know 1 is the identity element of multiplication. It does not change anything. So if I took the 2x squared here, I also divided. That is why I was left with 1 here. And when I divide by 2x squared here, I'm left with cos theta. So whatever question may appear to you to be formidable, please note, if it is right-angled, don't bother with the rules, sine rule, cosine rule, area rule. Just use the definitions of sine, tan, and cos. And also with the area, just use the fact that the area of a triangle is half base times height, because you do have the height and the base. But if it is non-right angled, then use the sine rule under normal circumstances. But if you have a square or a square root, and the triangle is non-right angle, that suggests that you use the cosine rule. And you need to know what the sine rule says, what the cosine rule says, what the area rule says, in order to be able to apply it. If time permitted, we would then go to a question that requires us to use the area rule. But anyway, I'm sure you get the picture. It was nice presenting to you. Hope we'll meet again in future. God bless you.